Okay, just restarted my stream. Just realized there's something I needed to do. Um, Pulling up my stream. Okay, good. All right, pour my beer. Next order of business. Most important part. No, I'm not eating food on stream anymore. So this is not a mukbang video, unfortunately. Maybe people that want that, you can go somewhere else for a mukbang video. Um, okay. Damn, that's a good beer. That is a really good beer. Okay. Feeling it's just so good. I would highly recommend Feeling Hazy. If you get your hands on it, it's a fantastic beer. I don't know how you get it out of state. It's possible to get it out of state, I'm sure, but I just don't know where you would go. It's brewed in Utah. Distributing beer in Utah is already hard enough as it is. I don't know how distributing beer from Utah to outside of Utah works. If Utah's bizarre liquor laws, I don't know. I'm assuming it's possible. I do want to capture on my stream. I'm just realizing I want to capture audio because the Pico console has audio. We haven't really messed up it yet, so there's been no need, but if we start playing of sounds today, that would be helpful. Okay. Okay. Oops. What's going on right now? Is that caps lock on? Okay, I guess my caps lock on. That's weird. Okay. We're gonna go to the directory that contains the game we want, and we're gonna load that. Okay, cool, we're in. It's taking account of things real quick. I'm trying to remember what I was doing last time. I believe. Oh yeah, that's an extension for Love2D. Um, something I can make games with Love2D as well. After besides the Pico, there's also that's another Lua based kind of like simple game dev framework um, that I've experimented with. I like it. It's it's fun. It's easy. It's quick. It's kind of easy to make a quick and dirty game with it. Um, okay. How do I close? Oh yeah. So I believe what we had accomplished was you know what I'm gonna do. Um, I'm kind of tempted. Well, we'll first look at what we did. We got kind of animated sprites going like so. I'm doing some logging there in the print console, as you can see. You can kind of see um, the speed with respect to a certain direction. Um, and then we got this kind of camera thing on. Notice how there's a bit of a jumpiness going on here. Trying to figure out what's up with that. Um, I'm noticing um, yeah, that's a quirk that I forgot about of the way that we handle kind of these. I like it of the toggling the animation is that it's kind of technically only toggling what's within a certain view of the camera. So when we go outside of the camera, it's gonna stop toggling, So we're getting kind of like these different animation states of some of the tiles because they're paused when they're kind of outside of view. But I kind of like that. Kind of I'll keep that in for now. Add character to the game. That's interesting. Anyway, okay. And let's go back to the editor. So we had we have a map that we can kind of draw from. So I'm really tempted to hmm, let's go back to the camera reference. So this is again setting up some draw state. We're basically just telling the draw state where a camera position is, um, and then future draw calls are offset from that camera position. Seems like some other calls are also offset from the position. It's kind of unclear to me which ones. Here in the documentation, actually it's not the documentation, so that's good. The way camera works is somewhat unintuitive. So if you might expect to use camera to put the camera in the middle of the screen, you actually use camera -64, -64 to move the screen so that its middle is in the front of the camera. This is probably because camera sets a screen variable that is invisible used by all draw functions. Okay. Hmm. Yeah, the reason why I'm using this camera is because it seems like it's best used in conjunction with the map call. Um, but so yeah, the this map is relative to the camera. As you'll see in this example here, um, they set some camera positions, upper left portion of the camera. Um, they set the camera position. They call map, and it's going to be relative to where the camera's at, basically. Hmm. Set the camera. Wonder why that would be useful. Let's see what that does. Hmm. Where am I setting the camera at? Got a lot of stuff here. This is the update function. Wonder why I just have this draw game function. Just get rid of that. Just inline the one thing we do. Draw the map. Tell the player to draw. So we're setting the camera in the update function. Okay. I guess that makes sense. I wonder why I would do this though. So let's go back to their documentation. Um, hmm. Let's see what that does. I'm just kind of curious if that's necessary. Doesn't seem to change much, thankfully. The jumping is still there, but that's wondering if that's a frame hitching thing more than a problem with the animating. Um, cool. Okay. So here we have this code for finding out how to animate things. We should probably abstract this somewhat instead of this update function. So wondering if the player's draw call being relative to the camera and the camera moving sometimes is we need to take that into account. It's like up here in the game. Basically, what's happening is that their speed increases once the camera starts moving, um, in a certain sense. No, they're always centered. Hmm, okay. So you have this animation toggle function. Okay, so here's what we're going to do. We are going to create, for now, um, let's call this get tile. I'm going to create an abstraction over tiles now. Tile, it's going to be the tile ID. Oops. Okay, so do that. Um, actually, we're going to do this. It's going to be like an object almost. An object in quotes in Lua. Table dot. This can be their ID. Um, And then hmm, table dot. So we want, is this happening in the update function? DT, create a function here. I believe that how we were handling this was more global. Um, where's it at? Right here. I kind of like that because if we did all the logic for figuring out if it needs to toggle inside of each tile we create, that's like a lot of work, redundant work. Whereas if we do this once in the update function, um, I feel like that saves, that'll be more efficient, even though, um, yeah, let's go with that. So really, we're going to make this function called animate, which is just going to be it's switching states basically. And then the tile is going to figure out, sorry, if how what it needs to transition to, if that makes sense. So what we want is basically what we want is, let me think, sorry, is a tile to kind of have its current ID and then a mapping of what to toggle to. Okay, then we're going to do mset, call x, call y, and then toggle at ID. Actually, there you go. So that way we kind of keep that. Okay, and then what we can do now is kind of create some definitions. Actually, that doesn't need to be local. We'll create a lava tile. Tile map, or rather, we're gonna create a mapping of tiles. Let me think. About the easiest way to do this. Let's see. Because we're just going to make another function called get tiles. This will be called lava tiles, lava tile toggles rather, which is going to be a dictionary. So that's 33 and oops, and 34. Okay. So 33 maps to 34. 34 maps to 33. I think that's how dictionaries work. Okay, yeah. So this is just the mapping of the transition states for lava tiles. So if you're in 33, you go to 34, and then vice versa. So that's lava tiles. And then we have for lava surface tiles. Lava tiles. Okay. I believe that would be 49 to 50. Cool. Okay. Then now we can return a table that maps 33 equals tile lava surface tiles. 34 equals tile. I'm trying to think if this is efficient or not. There's probably a better way to do this, but that's fine. Lava tiles. 50 equals tile. 50 lava tiles. Okay. All right. Let's move this up above. Calculate dt. Let's do that. Okay. Then we'll scale the tiles. That'll be the current animated tiles. Okay. Accurate. This is going to get downcased anyway. I'm being inconsistent with the naming conventions here. Now that I think about it. Hmm. That's why you don't drunk code. Well, I'm not actually. I take that back. I'm snake casing, generally speaking. Okay, so variables are camel case. That makes sense to me. And then functions I snake case. This is like an object type, so it makes sense I would calculate that. Yeah, I'm being pretty consistent, actually. As long as I'm consistent, whatever. Okay. Oh, yeah. There you go. will be consistent. Yeah, functions, all snake case. Variables, yeah. Functions are specifically like static functions. Um, they're like locals, I guess. They're not really like, I'm sorry, global functions, I mean. Okay, we got that. We got tiles. Okay, so now what we're going to do inside of here is we're just going to do, this gets us the tile ID. Tiles at S. If tile, then, so if it's one of the animated tiles, then we're going to go tile dot animate. And it's going to get animated at there. Okay, let's see if, oops, let's see if this works. Also, the other thing is, you can get rid of this now. Maybe. Unclosed. Lava surface tiles is unclosed. That looks closed. Maybe. No. Hmm. Is this a Lua thing I'm missing? Those wouldn't be closed either. That's how I initialized dictionaries there. Anyway, the reason why I'm doing it this way is because conceivably you could have maybe 3 frames of animations at some point in the future, but so which is why I'm kind of having like this mapping of transitions that we kind of create 33 transitions to that. But conceivably, I could have this go to 35, and then 35 goes to 33, I add in additional animation frames if I wanted. But if I was just kind of like committed to just only two animation states, I could just get rid of that and just have basically the link to the transition to in there, 33, 34, 34, get rid of this whole dictionary mapping entirely, which might be smart. Um, unclosed. First of all, I should do that. Got that. Maybe that's the problem. We will find out. Unclosed. I feel like am I losing my mind? What's going on here? That's just right there. It's closed. That is closed. Doesn't get more closed than that. What am I missing? Let's go into the code editor here. Looks closed there too. Hmm. Want to make sure I'm closing everything. Let's see. There's actually no reason to persist that because it will be scoped to here. Well, no, you do want to persist that because we're setting it there. Yeah, that's being changed, but this should be. We can just have this coming in from the function scope. Um, I'm kind of tempted to what am I missing here? That's a closing bracket, if I'm not mistaken. Let's just do this. And it condenses. Oops. Expected parentheses near equals. Closing bracket near equals. Hmm. Lua table initialize. Pretty sure I'm doing this right. It's one table. Do that. You can do. I'm wondering if it's the number thing that's the problem. Um, that seems strange. Lua table number key. Da da da. Really? Okay, that's interesting. So you have to do this, which seems anachronistic. But whatever, we'll just do it. Okay, that'll fix that problem, hopefully. Oops. Okay, now let's run it. Okay, that's kind of that's some BS. Okay, there's no animated, so so that's good. Um, so let's see what we're. Oh, okay, so let's see. But there is moving though, so at least that works. So we're gonna have. Oh yeah, the most important thing. I forgot that key thing there. Okay, much better. Okay, there we go. Got that in there. Okay, okay. Whew. All right, that's some stuff out of the way. So we have a period that we update animations. We just kind of hard code it in there. We could probably make that like a global too. So in the update function, we just kind of make sure that we'll call this. Kind of want to rename this. To make it a bit more explicit. So after basically 0.5 seconds, we toggle animation states using the update function. And then that will involve every 0.5 seconds, basically going through all of the tiles, I guess, on the map with within view of the camera, and then kind of switching their animation states, or basically switching the tile that they point to be whatever appropriate tile the next state should be. But it's only the tiles that are in view of the camera, which is again kind of a quirk that I kind of like. That makes sense. Would it be more efficient? You could do that. Um, so we reset the animation state back to 0 after 0.5 seconds. Makes sense. Cool. Okay, we got that done. Feels like we haven't really done anything because we technically haven't, other than we just kind of did something that was, in my opinion, more of an optimization, a code optimization than anything else, but it was kind of one of those things that I feel like we should do. Okay. Oh my. That's wow. What did we do wrong here? Okay. No. Sorry. That's what we wanted to do. That was uh that was a mistake. Okay. Let's see what it looks like after. This is kind of their global. We'll call it animation um, interval equals. Let's try 0.25 seconds instead of half a second. Let's see what that does. Hmm. I like half a second, but I like being able to change it. So I might change my mind about that. Okay, so back on track. I'll grab another beer, but so next order of business. Want to fix that hitchiness going on with the player character, maybe, and then I want to get jumping working. Well, we want to get the part of the animation working about the direction that the player character faces. That's probably useful. Um, and then fix the hitchiness, get jumping working, and get jumping onto platforms working. So now we want to get we want to figure out what floors are and object and just blocking surfaces, stuff like that. So that's basically all I hope to accomplish today. So, which is kind of a lot. Doesn't sound like that much, but it's could be a lot. Um, I'll make a brief break to go grab a beer.
All right. This is an optional tab. Whew. Forgot to synchronize. I think you go this way.
All right. Yeah, that video um, was from my hike slash trail run to Grandeur Peak today, which is one of several peaks along the Wasatch Front above Salt Lake City. Um, it's a notable one. Um, it's not like the most epic one, I guess. The like when you look at like the mountains along the Wasatch Front, it's not like the one that's like there's one that people typically notice. Um, I imagine most people see Grandeur or not Grandeur, Mount Olympus in quotes, Olympus. That's probably one of the big ones. And then there's also like Lone Peak. Um, Grandeur is kind of like just above Mill Creek. And the Sugar House area. It's just like straight west or east of it. Sorry. Um, it's it's pretty, but it's like it's not like one of like the it's not the prettiest peak, you know. But there's a good view from the top of it though, of Salt Lake in particular. You have a great view. Um, Mount Olympus, you know, I've not done that one yet. I've not hiked it. I know it's like 3, 4, 5,000. I don't know exactly how many feet it is from the base. Um, doesn't look like a fun hike, which is why I haven't done it more than anything. It's not like I couldn't handle the hike itself. It's more like the cost benefit analysis of like, is it worth it? Is it going to be like, what's the scenery like? Is the scenery on the top superior? Like, how much better is it than the top of like Grandeur, right? For like the amount of work it is. And would I be better off just kind of like doing a prettier hike instead of that? Because the hike that you take to get to the top of Mount Olympus, there's probably more than one way. But the one that I've seen look kind of boring. It's like you're climbing the face of the mountain that doesn't have a lot of trees. It's just really steep. It's a lot of brush. Looks miserable to be honest. If it were kind of coming from the east, like if you went up a canyon and then kind of like did a bunch of like switchbacks and then kind of came from like a ridge line to it, that might be fun. Maybe there's a way to do it that way. And I would do it. I would do that hike over doing it the way that I've seen on all trails. Okay, which doesn't look fun. Okay, close that. So, next order of business. It's not terribly exciting to just change code, but I feel like that the changes that we made are an improvement because it will allow us to add in new animated tiles more easily. Because then I would just update this get tiles method. I would create a new tile and then just kind of create like the mappings to the new tiles in here basically. It's a bit well, maybe it's just more straightforward, more robust, um, in my opinion. But it's not significantly different than what I was doing before. But I would say I prefer this approach. So, if you want to fix, let's look at how the player is being drawn. Sorry. So we This might be one of those things where I could split it into a helper method. Okay, so that's what we're going to do. Function, animate, or animate tiles. And here I am doing what I said I would do. Um, but I want to clean up this update function to be, do I need it for here? I might need it in the player update for if I choose to fix it, so we should keep that there for now. But yeah, this is a much smaller update method. And then I'm just going to have this animate function kind of do a lot of the heavy lifting for updating the map. Test that that works. I'm also a very test-driven person, or at the very least, make test-driven in the sense that I make sure I didn't break something whenever I make potentially breaking changes. Okay, good. So that worked. Um, so any software engineer, developer worth their salt um, knows to very frequently test, make sure that the shit that you're doing hasn't broken anything. And what that means, you should know what that means when you're doing your work. So you should be doing the work of making sure that the work that what you're doing isn't breaking things very frequently. The longer that you the longer that you go without doing that, the greater risk you are of having to spend a lot of work to figure out what you broke if you did break something. If that makes sense. So yeah, and you also test a lot. Also, you should know how to debug, quite frankly, which is something that I think that a lot of people that are starting to write software and program, um, that's one thing I recommend learning how to do sooner rather than later. It's very useful. It can make your life a lot easier. So anyway, okay, knowing how to debug and having like a scientific approach to it. So got that. So the update function here, I feel like it's pretty simple. Let's go into the player update now. Where is the player defined? There you go. I feel like I should just make this player. And now, init player, we'll just replace with, because it's basically a type constructor. Okay. Um, So we are drawing them at their position. I'm kind of curious what happens if we just change this to B0. Will it be relative to the camera? It is. Almost changes nothing. That's interesting. Fascinating. So now we're not even using their position. I'm trying to figure this out. I feel like that should have worked, if I'm being quite honest. No, okay. I am updating their pause down here. Okay, that's important. And the player's position is informing where the camera's at, which that makes sense. Okay, okay. Yeah, I was worried there for a second. I was like, that shouldn't have worked. Something's broken. Logically, that was just absurd. And up until I saw that we were updating the position still, we just weren't using it in the draw call. Okay, so here's the thing that we want to do for the player. Um, we want to have a move state. Do do do. Table dot state. Oops. State equals moving state. Okay. And then if not pretty sure. Okay. Or okay, I'm pretty sure these are keywords. Hmm. And not table dot state equals jumping state. So if you're not jumping, then okay, we can move that to the very end. So that makes sense. So you're moving, we enter a moving state. We're jumping, we're entering a jumping state. Let's get rid of that. Table. So we're not even using that. That's fine. Not sure we're using this. Maybe I should do dy. Okay. Table.delta.dx. Table.delta.dy. Okay. We'll do this for now because we're going to be working on jumping soon. Um, let's do this instead. I'm wondering if I have performance benefits to changing a reference to be a new object every time in Lua. I'm not sure how Lua works. Um, mm, whatever. I'm doing it with a pause down there, so who cares? Okay. Then when we draw them, so if table.state equals idle state, then style equals. Yeah, one. Else if table.state equals moving state, um, tile equals 2, I believe. Or hmm, if I should have like a jump tile. For now, we'll make the jump tile equal to the move tile. For now. Pretty sure it's gonna be tile 2. Let's check. Yep. And then let's go to the sprite function. Oops. I think that's the flip X. Okay, so we might already have that working. Let's check it out. As long as nothing breaks. God. Okay. Um, line 185. It's right there. It's because I'm stupid. Okay, there we go. Ooh, that's interesting. Well, we also got that flipped. Hmm. I think what we should do, table dot direction. So this is kind of how you do enums in Lua, from what I saw. Let's double check this. Lua enum. Yeah, you could do that. Seems right. Hmm. 1 second. We'll just do this. Okay. This is my version of an enum. Ignore this guy's approach to enums. That's his weird strings. Come on. Okay. Okay. Cool. Um, so yeah. The update function will just kind of persist whatever the last direction was. And then so you flip it if the direction is left. Wonder if this is what messed things up. Is this DT value? That's actually what messed things up, I bet. No, we're good there. Oops. Okay. Hmm. That's a line 152. Okay. Okay, well, at least that's working, the direction thing. So that's good. Boop, 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 boop. The position thing is broken. Wonder what I did to break that. Table.pause x. Table.pause.y. Just kind of curious. Okay. Should I stop setting the camera? I'm curious. Let's look into that. The camera looks like it's being set though. To camera. Hmm. So previously, did I move the where the draw call occurs? Is that what broke things? Update sets the camera. Draw uses the camera position. Wonder why it was working before and then it stopped working. I'm just curious. That seems right. Wonder why it would. Oops. Wonder why it would work before and then stop working. Interesting. So, hmm. So the draw calls are relative to the camera. And then we're setting the camera relative to the player's position, which is going to be their position. Actually, this makes sense. Hmm, yes. I always could change the camera position, but actually, this makes sense to me. Um, I'm just curious why I was working before. Forgot what I did to change things, but that's fine. Okay, so we got that stuff working. Now we want to get jumping working. Okay, jumping involves entering a jump state. Um, so I think we want to have local jump height. This is going to be the number of pixels that the character can jump. Let's say they can jump 2 times um, Where's it at? Cell size. It can jump 2 cells. So you initiate a jump. Give me a second. If button P, so you just press jump. Um, hmm. This is the instantaneous change in Y, but we also kind of want to have the table dot jump, which is going to be 0, your jump distance, which we're going to be keeping track of. Um, so you press the jump button, initial jump. We're going to set the table dot jump equals 0. We're going to set to 0 for now. And then we continue. This is going to like follow through. Then we enter the jumping state. That really, we'll have that handle that. Um, yeah, we're good there. This is the update function. Okay. Do, do, do. That seems fine to me. Um, we should make a function called get adjacent tiles. And then this is going to have the hmm, get tiles adjacent to player. It's a long name. Okay. So, okay. I think they have a, yes. Okay. So this is going to be their pixel position divided by 8. This is going to be the floor of that. So we're sampling into the map. Okay. And then we're just going to do return left. We'll just enumerate them like this for now. Equals mget. Px minus 1. Is that right? It's probably right. UI. Right. Equals mget. Px plus 1. py. Up equals mget px py plus 1. I might have this flipped because the seems like things start at 0 and then they go up. So here's 0, 0. In fact, yes, it's probably flipped. But px minus 1 is left still. I think that the y-axis is actually flipped. Um, I think that's technically correct. Yeah, we'll see. Because setting the character to 0, 0 puts them at the top left. Um, adding x moves them right, hence that. Adding y moves them down, hence up is technically subtracting from the y. This is why it's a little bit confusing. This is based off the OpenGL specification for their screen space coordinate system, probably. That's how OpenGL handles it too. Um, but does mget work the same way? That's what I'm kind of curious about. Let's check. Let's look at the map. Go to here. So yeah, that's 0, 0. Y is 1. So the tile above is going to be 0. Yeah, see? That makes sense. I mean, it makes sense in their perverse logic. Okay. All right. So we got that. This is going to be useful. Um, so you're starting a jump. So this order is going to be important because this, if a player is simultaneously moving and jumping, it's gonna override the state to be the jumping state, which is good. This is very stateful. This code, stateful. But I don't want to. The more logic I put into there to kind of like account for these different cases, it's kind of like I'm not sure what the Pico-8 processor, how good it is, but I'd rather just it is technically more efficient to just kind of do this than to add in like if statements here that are like if if the current state isn't jumping, then set moving, that type of stuff. I'd just rather just kind of have like the flow, you know, prefer the jumping state when, well, because this is only for the initial button press. Hmm. I might need to do that. Hmm. What do you think about this? I'd hate to have to add a check in there. Seems like I need states for, I need animation states, and I need other states. What we can't do is this. Boop. Um, so if not and table dot hmm, I wonder if I need to have different types of states, like animation states, control states. Yeah, let's do that. Okay, anim state. So does that make sense? Let me think. Oh dear. I'm just wondering. Let's do this. I'm not sure what moving state really is, because jumping is moving. It's just a form of moving. Um, which is fine. Maybe that's why we'll do this. If not table dot state equals jumping state, then. So if you're not jumping, then you can be considered moving. So if um, this seems like we might need to change it, but for now we'll go with it. So the update function should be calculating if table.state equals. Actually, we can do this after the control checks. Dun dun dun. Okay. So we're going to do some, trying to think if I should have a linear acceleration. Well, I mean, no acceleration rather, or acceleration in the jump. I'm kind of thinking we had max jump height, right? Where's it at? Somewhere? Jump height. There we go. That should be a local. That should be a global, just like the other globals I have. Okay. And then we're going to have a gravity coefficient, which we're just going to make it, it's going to be like the rate of acceleration. We'll make it 0.98. Wait. Yeah, we'll go with that. I should actually make it an integer to make my life easier. Okay. Then what we do is table dot. So the dx there. Table dot delta dot dy equals um, there we go. So if it's 1, um, hmm, well, we're starting from 0. This is going to stay 0. Ba-bum. What if I should do this? This is 1 plus. You're always adding 1 pixel. Screw it. This will accelerate. Okay. That's what we want. So if it's 0, it goes up to 1. If it's 1, it goes up to 2. It's going to be increasing every time. Yeah, that makes sense. It's increasing at the same rate, but if I did this, so then it would be 0 plus 1. 1 times 1, 2. 2 times, yeah, it's going to be the same thing because gravity is set to 1. I get this. Just linearly increasing for now. If table dot height, table dot jump height, then, oops, okay. Equals the min of jump height and then table dot pos dot y plus table dot delta dot dy. That makes sense. So we don't want to go more than the max jump height. One second. It's going to be, is that right? I think what we want actually is this. Programming and drinking. Okay, let's see. We actually want the min of Let's see. There's an efficient way to do this, and I've just had too many beers to actually do it. So we'll do this. Uh, if table dot jump plus table dot delta dot dy is greater than jump height, then table dot delta dot dy equals minus. So the jump value plus the change so you kind of subtract the difference that is over the jump height. Okay, that makes sense. So yeah, if this is going to be more than the max jump height, basically the delta, then we're going to adjust the delta to just be no more than what it takes to reach the max jump height. If that makes sense. So dy minus how much over the jump height it was. Okay, makes sense. That seems good. And then we're going to do this. Else if. So basically, we're in a jump state, but our jump wasn't less than the jump height. Bum, bum, bum. So I'm worried about floating point arithmetic error. I need to add some epsilon stuff into here as well, but for now we're good. I think by keeping the gravity coefficient integers, we're good. So we're going up or we're going down, basically. Out. Table dot delta y dy equals. You've reached your peak. There's probably a better way to do this, to model this. You could just make this like a parabola. That's actually not a bad idea. So basically y is going to be equal to, but we're kind of allowing people to move. How should I put this? Jumps aren't going to be parabolic here. We're actually kind of like allowing some fake physics in here by allowing people to kind of move horizontally while they're in the air, which kind of messes things up a bit. So unfortunately, we can't really use parabolas to model jumps in a platformer. Um, Otherwise, I could just have y be equal to x squared, plus some constants and stuff. Um, that's not a parabola. Anyway, sorry, I'm tired. Um, so what a jumping state? We're either less than the jump height. Well, this presents a problem here. Table dot delta dot dy is greater than or equal to 0, or rather and. There's a better way to do this for sure. So you either, and we kind of want to flip this because our coordinate system is actually down is negative is up, positive is down. So that kind of changes things. So we want dy to be less than or equal to 0. Ay, ay, ay. That means you're going up. So basically, you haven't reached your change in y hasn't reached next yet, but you're going up. Else if dy less than or equal to 0. So here you were on your way up, but you reached your max equals table delta ui. We're just gonna flip it in this stage. I don't like this, by the way. So we're gonna find a better way to do this when I'm not drunk, slightly. Else table. So it just occurred to me, you're not going to always reach your max height. You might jump up and to hit a block or something. So in which case you're going to want to basically just switch directions there as well. So the logic is kind of already making a lot of assumptions. I should have thought this through more. Um, so it's going to do this. Basically, start from scratch. Sometimes how things go when you're programming. You realize everything is flawed and you can do better, which is fine. So we have a max jump height. That's fine. That's useful. We have how far a player jumped that we're keeping track of. That's useful for knowing if you've kind of exceeded your max jump height, but maybe there's a better way to do things. Really, I think what we want for now to keep things simple. We're not going to have any acceleration. So it's gravity stuff. We don't need like a value for it necessarily. To keep our platformer simple, and then we can go in and add in gravity as a feature afterwards. Let's have more time to think about it. Um, how I want to do it from a game context. Because again, what complicates things is the allowing control while you're in the air, which is something you can't physically do. So most ways I have of modeling jumping and physics and trajectories operate off of certain assumptions, and I'm not in the mood to problem solve that, or not in the state of mind to problem solve that at the moment. Rather, so that's fine. Um, but what we can do, what we basically want to do is we're starting to get into collisions and colliders. So um, I want to play Doom, and I think I want to take a break from this. Let's see how long I've been recording. Dear God, 2 hours. Okay, I'm gonna take a break. I'm about at my limit, so I think I'm gonna just stop the stream now. I've hit my 2 hour um, point somehow. Wow. I'm gonna have to think this through in terms of like, so we're dealing with colliders. I didn't get to the point where we did jumping, unfortunately. We're dealing with collisions. We're dealing with jumping. We're modeling the trajectory. You're potentially going up. Maybe you're hitting something above you, stopping. Then you're going down. Then hitting the ground. Um, so to me, we can model that in terms of you're in an up state, you're in a moving up state, then you're in a moving down state. So we need to add another, basically we need to add two states now for jumping. You're going up, you're going down. You jumped and you're falling. Seems pretty straightforward. And then again, we can kind of try to gold plate and add in gravity and acceleration and stuff like that for physics, kind of like toy with the physics model and the gameplay model maybe a bit later. But honestly, I think having no rate of acceleration, but just having it be linear from a gameplay perspective actually might be better, more fun. Um, I think a lot of games might defer to that approach too. I think what we could do is do what would you call it, um, like a tween, basically a motion tween, having like a fast initial kind of like acceleration and then kind of like a fall off into the jump. So you kind of a tween. You're going fast initially. So I guess we could kind of experiment with stuff like that. But like animation tweens. But we don't need to do too much of physics beyond that, I think. Um, so yeah, once we have a jumping state and a falling state, um, detecting collisions, knowing when we collided with something, and then kind of changing the state to the falling state, basically when in a jump, that type of stuff. Um, and then I'll probably get more into dealing with state machines in general with the player, so that we can kind of like avoid future bugs that might involve being in the incorrect states for things. So if we kind of like modeled all of the potential states that the player could be in, um, and then the potential transitions between the states, that might prevent really esoteric bugs from happening. So if we kind of switch over to like state a state machine for the player and controls, that'd be like a good way to kind of like prevent weird bugs from happening instead of like hard coding and all these different kind of like the transitioning of states into like these random places. Now we're just kind of like modeling the code to be designed around state transitions and states. So basically, we have a state machine. We're building state machines for the characters to transition from, as opposed to implementing the states and the state transitions in the code. So that might be a good thing to do. Anyway, I'm done. I'm gonna play some Doom.